Hi, welcome. Today we're going to talk about differential equations. What are they? What are the related things? It's called an initial value problem. And let's do some examples. Right now we're not in a position to explicitly solve them. Maybe you can guess. But otherwise we're mostly going to check the answers to differential equations. But before we do, we have to know what a differential equation is. A differential equation, simply put, is an equation that involves derivatives. So it's an equation involving derivatives. Now what are some examples of that? A very simple one, y prime equals 2x. Can you think of an answer to that one? What's some function whose derivative is 2x? Hopefully you can think of one. X squared works. But so does x squared plus 6, so it's not a unique answer. More interesting ones involve both the derivative and the original function. So for example, y prime equals 2y. Maybe you can think of what that one would be. That's tricky. We haven't had the chain rule yet, so you may not know how to do this one, but there is an answer. Here is an answer. This is not the only answer, but it is one answer. Y equals 2e to the 2x. And you can use the b to the x rule to solve it, but it works out. Another example, maybe a little more complicated. Y double prime minus y prime plus y equals x squared. I'm not going to try to solve that one right now, but it's an example. It involves derivative. It actually involves the second derivative too. They can get even weirder. Here's one. Y times y prime times the square root of y double prime plus 1 all over y squared minus 1 equals 6. This one is ugly. It's messy. That's a technical term. Actually, it's not. But this one, all of these so far over here are what's called linear differential equations. All the terms are really by themselves, and that's nice. This one, they're mushed together in a very unappealing way. So the answer to this one is much, much, much more complicated. But, as I said, solving is really beyond our scope right now. What we really want to do is just see whether or not functions work. So here's a question. Get rid of that for now. Here's a function, x squared plus 1. Does that solve the differential equation 2y minus y prime x is 0? Does it? How would you know? Well, by plugging it in. Let's test it out. 2 times x squared plus 1 minus y prime. We need the derivative of this, hopefully. By now you know the derivative of x squared plus 1 is 2x times x. So what is that? 2x squared plus 1 minus 2x squared. If you do all of that, what do I get? I get 1. It's not 0. It's almost 0. It's kind of like 0. It's got a number, but it's not the same. So the answer is no. It does not. How do we find something that actually works? Well, hopefully from this, maybe you can kind of piece together the answer would be without the plus 1. Why? That would work out. But again, that's just ahead of us. What we really want to do is know if it works. The answer is no. So now, there's one more step in the puzzle of differential equations. It's called an initial value problem, or an IVP. Initial value problem is a differential equation plus an initial condition. So for example, show that y is 2e to the x does in fact solve the initial value problem. Notice this. There's a differential equation, and here's an initial condition. What does this say? Y of 0 is 2. Normally when we write y's, we don't put anything after them, but if y here is a function, the variable, the x or whatever it is 0. So let's try it out. First of all, test that out. What's the derivative of 2e to the x? The derivative of e to the x is e to the x. So y prime is 2e to the x. I'm not going to write equals. I'm going to write a different symbol. Equals check. This means we don't know if it's true or not. We want to know if it's true. And there's what y is. Is that true? Is 2e to the x equal 2e to the x? And the answer, of course, is yes. Then, y of 0. 2e to the 0 is that equal to 2? That's the equals check. It's not setting it equal, it's the wonder if it's equal. Well, e to the 0, anything to the 0, is 1. 2 times 1, 2 equals 2. Check. So yes, it works. Which is good, because I didn't ask if it worked, I said, show it works. Let's try one more, just to see if differential equations work. If they've sunk in, we can probably try something that's not first order meaning it's got a first derivative. But let's try a second order differential equation. I want to know, does y equals x e to the x solve the differential equation? Y double prime minus 2y prime plus y is 0. Does it? Try it out. You're going to need to find out what y prime is, what y double prime is, and plug them in. I'll give you 2 seconds. Okay, did you find out? Well, let's do it together. Y is equal to x e to the x, and if you did it correctly, y prime should be x plus 1 times e to the x. You may have had 2 separate terms, that's fine. If you did it correctly, you'd have y double prime is x plus 2 e to the x. And again, you might have had multiple pieces there, and that's fine. Let's plug those in. Well, y double prime is this. So we have x plus 2 e to the x minus 2 of these, x plus 1s, e to the x, plus just one of those, the x e to the x. It looks messy, and again, we don't know if it's 0. I'm putting a check question 0. Is it equal? Is it not? Well, let's do it. Let's now, since we have to simplify all of these, factor e to the x out of everything. And I'm going to do that first. E to the x, and what do I have if I pull the e to the x out? X plus 2 minus 2 times x plus 1, so minus 2x, minus 2 plus x. Is that equal to 0? X minus 2x plus x. Well, look, cancels, cancels, cancels. 2 and minus 2, cancels, cancels. Nothing's left, it's 0. So the answer is yes. Check, and yes, it does. How did I know that was going to work? Well, if you take a differential equations course, you'll learn all sorts of techniques to solve second order and other order partial or linear differential equations. Partial differential equations is, of course, some other topic, which is well beyond that, too. But this is a huge field, it's very interesting, and hopefully I've sparked your interest. Until next time.